Hi everyone, welcome to our channel. We will continue our mathematical optimization series with the second video. In the first video, we showed how to install Groby and the GrobyPy package on Python. If you haven't watched it yet, you can watch it with the link above. In this video, we will talk about linear programming and show how to solve them using the GrobyPy package in Python. Let me first briefly talk about the linear programming. Linear programming is a widely used field of optimization for many decades. Many practical problems can be represented by using linear programming. It's a special case of mathematical optimization. Linear programming is a method to achieve the best outcome in a mathematical model whose requirements are represented by linear relationships. In this type of optimization, there exists a linear objective function and linear equality and/or inequality constraints. Constraints make a feasible region, and we are trying to find the best point in the feasible region. Let me introduce the standard form of it. The standard form is the usual and most intuitive form of describing a linear programming problem. It consists of following parts: a linear function to be minimized or maximized, and the problem constraints of the following form. Other forms, such as maximization problems, problems with constraints on alternative forms, as well as the problems involving negative variables, can always be rewritten into an equivalent problem in the standard form. Let us create an example of linear programming and code it in Python using the GrobyPy package. Assume that we have a minimization problem with the objective function of 5x plus 4y, and there are constraints that our solution needs to follow. We have three problem constraints and two non-negativity constraints. First one is x plus y greater than or equal to 8. Second one is 2x plus y greater than or equal to 10. And the last one is x plus 4y greater than or equal to 11. And as I said, we have two non-negativity constraints for x and y. Let's have a look at the feasible region created by the constraints. In the graph, we have 5 inequality constraints, where 2 of them are the non-negativity constraints and 3 of them are the constraints above. Namely, the orange line represents 2x plus y greater than or equal to 10. Blue line represents x plus y greater than or equal to 8. And the green one represents x plus 4y greater than or equal to 11. The gray area shows the feasible region for our problem. Now, we will show our objective function line in the next graph. This graph shows both the feasible region and the objective function line. With the current graph, the solution is not feasible since the objective function line and the feasible region are not intersecting. We aim to intersect both of them, resulting in the minimum objective function value. To do that, we need to pull the objective function towards the feasible region. In the third graph, the objective function intersects with the feasible region. Actually, it is the optimal solution. We can calculate the objective function value by using analytical geometry. Also, we can code it and find the value of the objective function and the corresponding x and y values using the GrobyPy package. Let's move to the coding part. First things first, we need to import the package GrobyPy. You should remember this from our first video in this series. After importing the package, we now create our model. The function model is a model constructor. We can give a name to our model. Note that it is not necessary to give a name to the model, so it is optional. The function returns a new model object, and initially the model contains no variables or constraints. Let us define our model as opmod and give a name linear program. In the next step, we add decision variables to the model. We use the addVar function. There are many optional inputs for this function. We can specify lower upper bounds and the objective function coefficient. We also state the type of the variable and can give a name to the decision variable. We define our x and y decision variables, stating their names, lower bounds, and the type. In step 4, it is time to define our objective function. We use model.setObjective function to specify the objective function. There are two inputs. First, the objective function as an expression, and the second, the sentence. For our model, we define objective function as 5x plus 4y, and the sentence is grb.minimize. The next step is adding the constraints. We use model.addConst function to add our three constraints. Remember that we have already added the non-negativity constraints when we define the decision variables. We add three constraints by using the function. First, x plus y greater than or equal to 8. Second, 2x plus y greater than or equal to 10. And third, x plus 4y greater than or equal to 11. If our model would have an equality constraint, then we only need to write equality instead of greater than or equal. Now we are ready to solve our model. We will use the optimize function. As the name suggests, it optimizes the model. Note that the algorithm used for the optimization depends on the model type. We have also another comment, which is the write function. This function writes the model to a file. With this function, we can output our model and solve it on another PC. Let us solve our model by writing optmod.optimize and optmod.write. As you see, the model is solved using the Groby optimizer. You can see the details regarding the solution. At the last line, you will see the optimal objective value, which is 34. As the last step, we will output the result and the corresponding decision variable values. To do that, we will use objval and getVars function respectively. Since we have more than one decision variable, we use a loop to print them all. When we run the code snippet, and the code output is the following. Our optimal objective function value is 34. The decision variables x and y are found to be 2 and 6, respectively. Thank you for watching. Please do not forget to subscribe to our channel. If you have any questions, please let us know by writing a comment below. Thank you.